Hello, my Ramda curious friends. It's time to start working on video or on not videos on functions that start with the letter S. So let me get back to where I was supposed to get to. Here we go. There's a lot of functions that start with S, but there's a lot of functions that are similar. Like there's a bunch of sort functions and a bunch of split functions. But we're going to start with scan. I apologize for not cleaning up after the last video. Let me just do that real quick. All right, so scan. Let's check out the type signature. We've got a function that takes a and a b and returns an a, and we pass in an a and a list of b's. So I'm going to assume that this a is here and a b goes into here. Um, yeah, because it says see also reduce and map a cum. So this is like a reducer function. So A is probably the initial value of the accumulator, and B is the item in the list one at a time. And then we return a new list of A's. Um, so scan is similar to reduce, but returns a list of successively reduced values from the left axis of blah, blah, blah. Um, and then let's take a look at this guy. So the first thing is a function, the iterator function, which I call the reducer function. It receives two values, the accumulator and the current element from the array. So that's just like reduce. And the accumulator value, A, also just like reduce, and the list to iterate over, just like reduce. It returns a list of intermediately reduced values, right? So this is why it says like map accum. If you remember that one, map accum is more like reduce and map at the same time, and it gives you back the reduced value, but it also gives you back um, a list of mapped values, like for each step. Um, and so this is kind of like in between, I think. So like we'll use my list of numbers. So this is a d dot list is just a an array 1, 2, 3, 4, 5. Just stops me from making an array. So they use the factorials example. Clients are always asking for factorials, aren't they? Um, and if we log that guy, oh, we're going to need to do that. Yeah. And let's partially apply it. So r.multiply is going to be our reducer function. And 1 is going to be the initial value of the accumulator. And then all we need to do is pass it call it and pass it with a list. So we'll do factorials, or not a list, but yeah, a list uh, of d dot list. Let's give that a go and see what we get. Yeah, and there we go. So our list of 1, 2, 3, 4, 5 is what we're working with. Yeah, so the factorial of 1 is 1. No, the factorial of 0 is 1. Um, okay, now I don't remember if my list is 1, 2, 3, 4, 5 or 0, 1, 2, 3, 4. D dot list. I think it's 1, 2, 3, 4, 5. Yeah. Okay. So the factorial of 1 is 1. Factorial of 2, remember it's showing each step. And I honestly forget why the factorials start with 1 and then okay, so 1 and 0 is 1. or one time, wait, no, one times one is one, one times two is two, two times three is six, three times four. Yeah, I can't remember exactly how this works, but it's it's giving us the final value 120, but it's also giving us each value in each step of the reducer. And to me, this looks cool because like I could do a undo history with this if I wanted to. Let's go with add. And that'll be easier. And call this sum. Yeah, there we go. And let's start with the initial accumulator of zero. Yeah. Okay. So the initial value is zero, and then we add one to it and we get one. And then we add one and two and get three, two and uh three and three gets six. Okay. So it's the accumulator that's always being added to the list. So this is each step of the accumulator, and then the final value of the accumulator is the last item in the list. So you could always get the last, apply the last function to it and get the last one. So if I go back to, well, if I start with zero and I just change this to r dot reduce, it should still work and just give us 15 or an error. Uh, oh, wait, no, r dot reduce. Oh, yeah, no, we're going to need to still pass sum, and our value of sum here is already partially applied. Yeah, no, 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 this isn't going to work. But what I could do is I could say r dot reduce and pass in r dot add the reducer function and start with zero. And what I expect now is if I call sum, which I've made with r dot scan, and pass d dot list to it as our data, the first one I should get 15, and the second one I should get all the steps here with the last value being 15. That's what I'm expecting. And that's what I got. Yeah. So short version, scan is like reduce, but it gives you all the accumulated values, not just the final accumulated value. Yeah. So that's scan. Pretty cool. Let's move on. Let's go to sequence, right? And then let's skip it because this is all Fantasyland stuff. And I've made great progress this weekend. They're learning this stuff. There's an article in the Ramda GitHub page. If you go to the wiki, there's an article about functors and applicatives. And gosh, I started there and I just clicked on links. I wonder if it's from there or if it was linked to, but there's something about of an article explaining them with lots of pictures. And I found it easy to understand. Of course, I've also looked into it in the past, so it may just be that I understand that article along with the other ones I've done in the past. Still, I'm not ready to explain it. I'm barely ready to explain stuff like scan. So I'm going to skip it for now. And we've already looked at set because we looked at that with lenses in the previous video, the little detour video I made, which was the last one. So we'll just pick up on slice. And I think we all have the concept of slice. It's on the array.prototype. This one takes two numbers and a list or a string. And if you pass it a string, it gives you back a string. If you pass it a list, it gives you back a list. So the first number is the start index, inclusive, and the last number is two index, which is the index, which is exclusive, and then it returns the list. And in this case, a list could, or I'm sorry, it takes a list, and then it returns either a list or a string. Um, so returns the elements of the given list or string or object with a slice method from the from index inclusive to the to index exclusive and some other stuff. So let's say we've got r dot slice, and we want to go from the first element, and then what happens if we don't pass an element here? We just invoke it with nothing, because in slice, with the array dot prototype slice, like it's optional value, but none of these are optional. I mean, it's expecting a certain amount of values, so you got to pass it like reduce. Um, and then d dot list. I don't expect this to work, but if it did, it would give me back the entire list of 1, 2, 3, 4, 5, and it doesn't. But if I said two, I'd start at the first index and get two items. If I did, oh, here's what they do. They use infinity, and that gives me the whole list, but a copy of the list, right? So this is one way to make a shallow copy. Um, and you can do backwards. So I can say to -2, which would be the second item in the list, 0, 1, 2, 3. Yeah. The only thing that confuses me is like the inclusive exclusive thing. So I think of it as like you start on this item and this is how many items you get, or how many items you slice. Um, if you did, use their example, you said Ramda, I would get Ram. Yeah, and that's slice. So, and you could do like, I mean, there's like a take two, there's a take function that we'll get to, but I bet you could make like take two equals r dot slice 0 and 2, and then we get raw, raw. Yeah, and that's slice. I don't think we need to go too much farther into that. I think we know what slice is, but super useful when you can curry or partially apply, I should say. Let's clean that up and let's do a couple more. So we've got all the sort. Now, full disclosure, I've never messed with bubble sorts or all the different fancy sorts. I mean, I've seen like coding, what do you call those things? Where you like do like a 24-hour coding blitz with people where they try to come up with their fanciest sorting algorithms. I just use sort. I just use the sort function. That's always been good enough for me. Um, let's start with the definition first, or the description first. Sort returns a copy of the list. So that's the first thing. Reverse in JavaScript mutates the array, but now there's a to reversed method that you can use to replace that, which returns a copy of the array and does not mutate the original. So it returns a copy of the list, sorting according to the comparator function, which is going to be this first function here, which should accept two values at a time and return a negative number if the first value is smaller, a positive number if it's larger, and zero if they're equal. Please note that this is a copy of the list. It does not modify the original. They start with that, end with that. And then see also ascend and descend, which was looked at in the original series that Chris did. Yeah, so we give it a list of A's, and it's taking two A's at a time, two consecutive A's in that list, and it compares it. And if like the first A is bigger than the second A, you get a positive or a negative. I can't remember. And this is another thing. I don't think of the mechanics of how sort works. And I think you can go and watch the video on Ascend to kind of more deeply dive into how comparator functions. Um, but it sorts things, right? And look how old that is here. So yeah, the diff function, they're creating a function that takes A and B and it returns A minus B. And then that gives you a negative or a positive, and depending on which, it's going to put the number in front of the other number or not. Um, but we could probably do this using just random functions and say r dot sort and pass in r dot ascend and our list. And so I'm going to make a list that's not sorted and say 3 2 4 or 5 1 32 and see if we get a sorted list. We do not. 3 2 132. All right, sort. Taking those two things. All right, so let's use their function, their comparator function. That worked. All right, so I need to go and look at ascend real quick and remind myself. So it takes a B, which has to be orderable, and it takes two, or it takes a function, takes A and B. Ah, it could be, the fact that the other one takes two A's, this one takes an A and a B. Or sorry, it takes an A and returns a B, so it only takes one thing at a time. The other one takes two. Makes an ascending comparator function out of a function that returns a value that can be compared with less than or greater than. Okay, so this is not the same thing. Yeah, so we just have to make our own comparator function. Because if I sort this with just like the array prototype, even if I just do two sorted, I think it's all lowercase. No, oh, sorry, I had the array. Yeah, it may not be. Let's just it may not to sorted may not be in Node. It may just be in browsers. Yeah. See, I get the same thing here. Honestly, I thought 32 would be sorted after three because I just think that's how that works. Wait, don't need that there. Yeah, there we go. Okay, so I was using the diff function here. But if you don't, it's just going to sort the numbers like alphabetically. And then, with strings, you don't really need one. But anyway, yeah. So the only key is you just got to come up with the function that you're going to use to compare the numbers. And I do notice it doesn't mention anything about strings. So does it work with strings? Hmm. Let's say A, C, B, Z. A, C, B, Z. So that doesn't do anything. And of course, R dot sort. What if we just did like R dot identity? Yeah, that doesn't do it. Um, and so normally sort is handles strings, but this doesn't. I'm gonna just peek real quick into, okay, so sort, we call slice on the list, and then we use the built-in sort method because we're dot chaining using the comparator. Yeah, I see nothing about strings, so I'm just gonna assume this doesn't work with strings and then move on and hope that assumption is correct. But I don't want to spend all day talking about sort because now we've got sort by and sort with. So let's just knock those out and then we'll pick back up in another video with the splits because we got a bunch of splits. So this one we sort by and it's taking a list of A's and returning a list of A's, but there is this sort function that takes an A and returns a B. And it's strange that it doesn't, like, if you return a B, then why are you ultimately returning a list of A's? Well, that's what you're doing up here. So a function in the list of sort and returns a new list sorted by the keys generated by function. Okay, so this is a key generating function. This sorts the list according to the supplied function. So here we've made a function called sort by first item, and we're using the prop 0. So we're dealing with arrays, so we're going to sort by the first item in an array, and then we're going to be sorting pairs. So this is pretty useful because otherwise, like, how do you do this? I'm sure there's a way, but we want to sort these pairs by the first number in the pair. We don't care what the second number is. And then if we apply sort by first item to our pairs, run that, we get -3, -2, -1 in order, regardless of what this is. If I change that to -3, we still get -3, -2, -1. And then the second value is just along for the ride. So that's pretty cool. We could do it sort by prop one, and then we'll get this one, and then one, and then two. So the third, the first, and the second. Third, the first, and the second. Yeah. Let's see what else we got. So we can sort names. So maybe this is why you can't just sort by strings up here. You use the sort by and provide a function for how to sort by strings. That may not be correct. Let's go through this example and just one step at a time here. See, I'm telling you, it's just the parentheses that make syntax hard to read. That's why I wish there weren't so many. Um, okay, so this one we're composing two functions together. We're gonna pass an object, we're gonna get the value of the name prop, and then we're gonna lowercase that, and that's our sort by name case insensitive. That's what we're gonna sort by, this lowercase prop. And so we're gonna need some data here. We'll put it at the top. So we've got Alice, Bob, and Clara each have names and ages. And for some reason, Claire's 314.159 years old. And then we put them in an array because that's what we need to pass is a list of A's. And then we call this function. So sort by name, case insensitive, and pass in the people. And we get, let's see. So we're getting the name prop, Alice, Bob, and Clara, and we are lowercasing it. So it would be lowercase Alice, Bob, and Clara. And that's why it's in that order. If we change the prop to be age, and then we sort that, we get an error because we can't lowercase an age. But if we incremented the age, I don't know why we'd do this, but just so we have two. Yeah, and I'm glad I did that because we're not actually incrementing the age. We're just like getting the age and we increment it and then we test that value and then it gives us back the object sorted, but it doesn't actually mutate this or give us back something else. And this is a dumb thing to do. What I probably could do is abs. Isn't there a math abs art on absolute? Maybe not. We'll just do math.abs. There's something similar to it. So if we do that, we're going to change this age to 10. And so we should get Bob, Alice, and Claire. Bob, Alice, and Claire. Yeah. And makes me wonder. Yeah. And here we go again, where like we're making absolute value. So we're looking at 101, 102, and 314. And I'm just trying to think if it's sorting it numerically or if it's sorting this like the numbers alphabetically. And I don't really care, to be honest with you. But this is how it works. You're just giving it the information of what to sort by because you're not passing in simple values like numbers or strings. You're passing in a complex value with like named properties and things like that. So you have to create a function that tells it how to um, what to sort by and how it needs to be sorted. Yeah, so that's sort by, and then we have sort with. And so sort with sorts a list according to a list of comparators. So a list of comparators instead of a supplied function. Okay, so that's interesting. Not sure what that means yet, but we'll get there. All right, so we've got our Sam. I shouldn't have deleted that. Let me go undo. Okay, so we've got our Alice and we got our people. And so we take a function that takes an A and an A and returns a number. So it looks like it's grabbing two consecutive A's from the list and then returning a number. And that number is probably going to be like +1, -1, or 0. And that's how it determines the order of the list. Um, so here we're going to use this function called age name sort. And so we've got a list of functions. So let's make that clear. Okay, so, and here's our descend and ascend. So I see what this is doing now. So, oh, this is cool. Oh man, I just realized what this did. So let's run this like this first. But let's call the correct function age name sort on our peoples. Oh, all right. So we get Clara. Okay, we're sorting by age descending. So 314, 101, and -102. That makes sense, right? Because we're sorting by the age descending. But what if old man Bob here was also 101 years old? And what do we get? We get 314, 101, 101 because Bob is after Claire. Uh, wait a second. We're doing this ascending or descending. Yeah, so we get 314, that's the highest number. And then since Bob and Alice are both 101 years young, I don't really know why. But my point is now we want to sort it by something else because like these two are giving the same answer. In fact, before I do that, let me just switch this to ascend. See how much different. I mean, we'll get Bob and Alice first and then Clara, but will we get Bob first or Alice first? And I think we might get Alice or we might get Bob first. Yeah, we get Bob first because Bob is first. Because we're ascent, switch it to ascend, maybe. I'm not sure. But my point is, we try to sort it by age, and then if we have two that are the same, then we can specify the next way to sort. And so we're going to sort by name, and then we get Clara, and then since these are both 101, and we're sorting ascending by name, then we get Alice and Bob. But if we sort of descending by name, we're going to get Clara, Bob, Alice. And we get Clara, Bob, Alice, right? Pretty cool. I mean, how do you even do that? Well, I guess what you would do is you would sort your data by age, descending, and then you would take that and you would sort that by name, descending. And you could do that in a pipe, but this is much cooler. Yeah, I like that a lot. And then I guess if you had another prop, I can't think of anything, so I'll just say X is 3, X is 2, and X is 1. And if we had two people named Bob, oh, I can't do that. Hmm. Yeah, I can't think of how to do, like, I need much more complex structure here. But my point is, like, we're sorting with this function, and then we're going to sort that by this function. I think this is a very cool function. I'm excited about this. This is on my top tier list with like converge and flow, apply spec, and some other ones I can't remember right now. Um, yeah, so we looked at scan, we skipped sequence, we already looked at set in another video. We looked at slice, sort by, and sort with. And then we're going to pick up on the next one with split. And there's like 5 split functions, and they're all pretty easy. So thank you for spending your time with me. Tell a friend, and I'll see you in the next video.